So this is a review 3 for microprocessors and interfacing CSE 2006 project. The title of our project is Smart City Automating Solutions for Our City. So our group consists of two members, myself Tamujit Roy 19 BC 1156 and Akash Patra 19 BC 1743. Now moving on to the next slide, this is the abstract of our project. So automation is the solution towards achieving an environment with minimum human intervention when it comes to reducing labor in essential day-to-day activities. The various specialized appliances like motion detectors, sensors, transducers, IR sensors, etc. in a smart city, which can be controlled by Arduino Uno and related specialized components and devices. The smart city will essentially have four components, which are smart street lamp, garbage level indicator, smart delivery truck and moisture sensing apparatus for detecting humidity and water. All this will be controlled by compiled programs and the hardware and software interaction. Now moving on to the introduction for our project. As you all know that cities are known to be the hotspots of human civilization from the time since human came into existence. Due to numerous facilities and opportunities, they have attracted humans from all the other corners of the globe. They are known to provide many life-sustaining facilities and basic amenities which increases the comfort in life and make life enjoyable. But today, due to increasing population and rapidly increasing demand for basic resources such as water, electricity, etc., and also to manage the waste generated by the citizens living in the conventional cities, the basic infrastructure no longer stands viable. To achieve sustainability of renewable resources and manage the waste in an efficient and effective manner, the concept of smart city is on the rise. More and more engineers, technologists, scientists, social workers, etc. are trying to contribute on this from multifarious levels to help achieve the idea of smart city on a large and practical scale. So in our effort to achieve the same and address the fundamental problems faced by the citizens living in the traditional cities, we have come up with a miniaturized model of a smart city to help minimize the problems faced by the people living in a city. We have essentially implemented 4 modules to realize this, which will be discussed in detail later. So now moving on to the next part, Akash will carry on.
So this is our project module. So we basically came up with the idea of making a smart city as our project, as we had the intention of providing some ideas to address the aforementioned problems and also to make the lives of people easy, keeping in mind the following points. Cities with smart systems and automated service facilities driven by centralized control systems are the requirement for the new generation people for improved standard of living and existence. The need for technologies-oriented IoT devices and services are required, which are really beneficial for making people's life easier. Some basic requirements of people living in a city has to be addressed, which affect their daily activities and have an influence on daily course. There is a dire need for minimizing electricity consumption because the resources are limited and no reliable, everlasting substitute for the conventional, non-renewable fossil fuels have been found. Automating is the key towards achieving a system with limited human intervention, which can reduce human efforts and save time with need for proper and efficient waste and garbage disposal system, minimizing useless water expenditure and wastage, demand for overall sustainable infrastructure. Now moving on to the next slide. These are the references sources. Firstly, the wireless smart street light control by J. Rawal, Dr. R.B. Patel International Journal of Science and Research. And second is an IoT-based smart bin for real-time monitoring and management of solid waste by Anika Banu. Next slide, please. The third one is the IoT-based garbage monitoring system by Banumathi A. And the fourth one is the smart irrigation system by S. Darshana T. Sanghavi and Sheena Mohan. Now move on to the next slide.
Okay, so these are the project components which we had made use of for making our project. So first of all, coming to the hardware requirements, we had used LED lights, IR sensor module, 9-volt batteries and its connectors, Arduino Uno, jumper wires, 220 ohm resistors, distance sensor module also known as the HC SR04, Node MCU CP2102 board also known as the Wi-Fi module popularly, robot smart car chassis, 200 RPM single shaft BO motor straight, soil moisture sensor, relay module, Tower Pro SG90 servo 9 grams mini or micro servo motor, the L298 driver controller module, power bank and an Android phone. So these are the hardware components. As already discussed, these are the basic description of the main or important hardware components like Arduino Uno, IR sensor, ultrasound sensor, Node MCU also popularly known as Wi-Fi module, soil moisture sensor, the L298N motor controller, the 200 RPM single shaft BO motor, the Tower Pro servo motor, the breadboard, some LED lights, 220 ohm resistors and the mini breadboard. Also jumper wires for making all the necessary connections wherever necessary. And now the software components which were made use of for our project are Arduino IDE 1.8.13, Node MCU card, it is basically a APK file which I will explain later in brief. And we also made use of the online simulation platform for IoT devices and processing devices called Tinkercad, and also Circuito.io for making the connections and simulating them. Now Arduino IDE is a very popular integrated development environment. It is basically a cross-platform application that is written in functions from C and C++. It is used to write and upload programs to Arduino compatible boards, but also with the help of third-party cores, other vendor development boards as well. Now the Node MCU car.apk is an Android packet file which we downloaded from the internet, having all the essential control for directing the smart garbage disposal truck to go in the directed ways. It has many controls, left, right, forward, backward, etc. It is downloadable from the internet and is used for basic calculations and making the car move in the specified direction as directed. It basically generates an Wi-Fi signal which then goes to the Node MCU module and it controls the Wi-Fi control car. Tinkercad is a free, kid-friendly online computer-aided design platform where users can design, modify and print 3D objects. It also allows students to design their own shapes or pick shapes to subtract from their projects, providing an easy way to create arches or holes using negative space as a tool. And also the final one, the Circuito.io is an online tool for designing complete electronic circuits. The Circuito app generates instant and accurate schematics and code for your electronic circuit. You select the major building blocks and it computes all the electrical requirements for your selection. Now the proposed modules will be explained by Akash.
So these are our proposed modules. Firstly, we have the smart street lights. So it will involve IR sensors that will detect motion and will turn on and off whenever someone passes by. The IR sensors will be responsible for detecting the presence of the passerby and thereby triggering the lighting up of the street lights by making use of the Arduino Uno microcontroller. Secondly, we have the smart garbage bin. Whenever the garbage levels in the bin become somewhat close to the brim, the specialized indicators will sense it and give an alarm message. It will involve a high quality garbage bin which will have a smoothly adjustable lid, having a carefully fitted ultrasound sensor just as the right orientation to measure the proximity of the upper layer of the garbage piled up in the bin. Now moving on to the next slide. Our third proposed model is the smart garbage disposal system, which is a fully automated delivery truck which will do delivery of goods and other essential commodities. It will be operated using a Wi-Fi module and a smartphone remotely controlled by a user. It will reach the desired destination near the garbage bin after it has been filled up by garbage up to a certain limit and dispose the garbage to the garbage disposal unit. So the fourth module is the smart irrigation system. It will sense the moisture levels in the soil and will switch the watering module. When the moisture levels fall below a threshold, it will be highly efficient as far as it comes to make use of the limited water resources, which if used for irrigation in a self-sustaining city might lead to acute water shortage. Now moving on to the next slide. Now we come to the implementation part. So this is the smart street lights. So basically what we are doing is that smart street lights will be capable of detecting the motion of the objects, for example car, pedestrians, etc. And the IR sensor modules will be used to turn on or off the lights of the LED bulbs. Two street lights capable of sensing the movement of traffic on the highway. IR sensors will be sensing the movement of the cars, part-wise switching on or off of the street lights when a car passes by a single street light. Energy efficient as at a time for a particular car only one street light is active. This mechanism is useful for saving electricity consumed by unnecessarily lighted up street lights. Now moving on to the next slide. So this is the implementation of 5 street lights using the Tinkercad. We have basically simulated the circuit diagram of the 5 street lights. So the smart street light setup consists of 5 blue colored LED lights, each attached to a rod, and the base of the rods are supported by cardboard holder. The wires attached to the LED lights are connected to the terminals of the breadboard. The connections are then extended to the Arduino Uno microcontroller's respective ports. Similarly, the jumper wires connected to the IR sensors are connected to the breadboard, which are then extended from there to the microcontroller. Now moving on to the next slide. So these are basically the links. The first one is a link for the Tinkercad simulation, and the second is a link for the Arduino file for the code of the smart street light implementation. Now moving to the next slide. So this is the picture of the implementation we have done physically. So as you can see, we have used the use and throw pins as the holder for the street lights, and these blue LEDs are represent here the street lamps, and as you can see there is an orange car representing a normal usual car and 5 IR sensors which are connected to the breadboard and hence connected to the Arduino Uno microcontroller. Now moving on to the next slide. Now Paul will explain the smart garbage monitoring system.
Okay, so the second proposed module was the smart garbage monitoring system. Smart garbage bins will continuously monitor the level of garbage in the dustbins and will turn on and off the LED lights based on certain criteria. So what are the criteria? The first one is the distance of garbage layer from the bin less than a specific threshold. The red light will be turned on, whereas the green light will be turned off. The second criteria is that if the distance of garbage layer from the bin is greater than or equal to a specific threshold, then the red LED will be turned off, whereas the green LED will be turned on. Upon the garbage level reaching the threshold condition, the Wi-Fi module driven smart garbage disposal truck will reach the desired destination near the garbage bin for collecting the garbage. The garbage collection truck will be remotely controlled by an Android app. This whole mechanism will be especially useful for disposing the toxic and harmful waste not to be disposed manually by scavengers or waste disposal spots. It will be facilitated by automation. So this is the Tinkercad circuit diagram for the smart garbage bin. The green LED light will be actively lit all the time, that is when the distance of the lower side of the lid and the topmost layer of the garbage is greater than or equal to 5 cm, until the distance between the lid and the uppermost layer of garbage becomes less than 5 cm, thus triggering a warning message in the form of the lighting up of the red LED light and turning off of the green LED light. So this is the basic diagram, the circuit diagram which we had made on the Tinkercad online simulation platform, and these are the useful web links for the smart garbage bin implementation. The first one is the Tinkercad simulation link for the smart garbage bin, and the second one is the Arduino file link for the smart garbage bin. So this is the physically implemented model for the smart garbage bin. As you can see, we had implemented or had our whole setup on a table. We have one Arduino Uno, one breadboard mini, some jumper wires, one ultrasound sensor attached to the lower side of the cap of the garbage bin, having some initial level of garbage in it, and the power supply is connected to the power bank, which we are going to show later. So this is the entire setup, and also we are going to make use of two LED lights, one green, one red, the functions of which are already mentioned previously. And now coming to the second component of the garbage monitoring system, which is the smart garbage disposal truck. It is made from highly sophisticated and rare components. It is responsible for carrying the garbage piled up in the garbage bin after it reaches the threshold condition to the desired destination to dump the toxic and harmful waste without human intervention. The highly complex and innovative car-cum-truck made from RC car chassis will have good quality wheels. The front wheel will be extremely smooth by the virtue of ball bearing and be able to move in all directions, while the two rear wheels will have sturdy structure with good treadings and solid grip. The two rear wheels will be run by two 200 RPM single shaft BO straight motors, which in turn will be controlled by the L298N motor controller module and the Node MCU or the Wi-Fi module. It will be controlled remotely with the help of an Android package file node mcu_car.apk by the concerned authorities involved in the managing of the waste of the city. The APK file will have a relatively complex interface having many direction controls in addition to the conventional left, right, forward and backward. It will have the subsidiary direction controls as well. This will be for making the movement of the truck as minute as possible and also as rigorous as possible. The operation of the truck will involve turning on the switch present on the truck for enabling the power supply coming from the two 9-volt battery. After that, with the glowing of the lights on the L298N motor controller, it is basically a high power motor driver module for driving DC and stepper motors. This module consists of an L298N motor driver IC and a 78M055 5-volt regulator. The L298N motor controller module can control up to 4 DC controllers or 2 DC motors with directional and speed control, having red illuminance and the light on the Node MCU. The Node MCU ESP8266 is a 32-bit Wi-Fi enabled microcontroller chip. There are total 30 physical pins, in which 13 digital GPIO port pins and 1 analog pin AO. Also there are 7 power pins, in which 3 3.3 volt pins and 4 ground pins are there. Also we'll explore about pinout of ESP8266, including its UART, I2C, SPI and other protocol related pins on the microcontroller having blue illuminance. The Wi-Fi on the Android phone has to be turned on. The phone will detect the Wi-Fi signal generated by the Node MCU. The connection will be default through the IP address of 192.168.4.1. After connecting the phone to the signal, the Node MCU.apk file has to be opened. Then the garbage disposal truck can then be operated in the desired direction after getting specific commands from the controlling authorities. As you can see on my screen, we have one interface of the app which we are going to make use of to give instructions to the Node MCU module and control the garbage disposal truck. So these are some of the web links. The first is the Node MCU board code link, which I actually transferred to the Node MCU board, and the second link is the APK file for the Node MCU car app. Now the next module will be explained by Akash.
So this is our fourth and the last module, that is the smart irrigation system. This system will continuously sense the moisture levels in the soil, making use of the soil moisture sensor, and will start pumping of water by the initiation of the servo motors, and will keep the soil moisture all through the day. This will be used for efficient management of water resources and for achieving an overall sustainable infrastructure of a city with its own agricultural fields and cropping patterns and more efficient crop production. This will be a substitute for sprinkler irrigation system. Also, it will automate crop irrigation system. Moving on to the next slide. So this is the circuito.io implementation of the smart irrigation system. So basically the smart irrigation system will consist of a soil moisture sensor, a relay module, a servo motor, water pipe and a high capacity power source. The soil moisture sensor will continuously sense the moisture content in the soil, and upon the moisture level falling below a particular threshold, the relay module will trigger the servo motor, which will pump the water from the reservoir through the pipe and make the soil moist. Due to unavailability of all the necessary components, this model couldn't be made physically and only a basic diagram is shown alongside. So as you can check, this is the basic circuit diagram which we have created using the circuit website. Now moving on to the next slide. So this is the web link for the circuito.io circuit diagram for verification. Now moving to the next slide.
So this is the smart city final setup, and we'll also attach the demo video in this YouTube link given below. As you can see, all the important components are shown here, and as mentioned earlier, the smart irrigation system model couldn't be implemented because of shortage of components, and also we ordered some components but they came out to be defective, so we couldn't implement that module. So this is the partial implementation of the other important components. As you can see here in this setup, we have the smart street lights, and also we have the garbage monitoring system consisting of the smart garbage bin and the smart garbage disposal truck. So this was the final setup for our project. So in conclusion, we'd like to say that the smart city agenda entails improving the citizens' quality of life, strengthening and diversifying the economy while prioritizing environmental sustainability through adoption of smart solutions. We had worked together on this project as a team, and while working together, our main objective always remained to keep in mind the basic needs of the common people living in a city. In an attempt to help minimize and sort the most basic and common problems faced by the people living in the city, we sought to address such problems and curb the causes of the same through our persistent and dedicated endeavor amidst the limited resources and materials in our hand. So these are the important references which we made use of for making this entire project. So that's all from this, and after this I will attach the actual video implementation of the project, so you can see that. And so that's all from our side. Thank you. So this is the basic model of our smart city. It is basically the miniaturized version of our smart city, in which I had implemented 3 components. The first one is the smart street lights. As you can see, we have 5 street lights here and 5 IR sensors as well. And this is a small car by which I am going to demonstrate the working of this smart street lights. So for the first component of our smart street lights, I had used 5 LED lights of blue color and 5 IR sensors, as you can see here. And I had made the connections, as you can see, in this breadboard by using this jumper wires, and I had connected the input and output terminals to this Arduino Uno. The power supply of this Arduino Uno is coming from this power bank. And the second component which I had implemented is the smart garbage bin. This is a smart garbage bin in which I had fitted one ultrasound sensor on the cap of this garbage bin. And the 4 terminals of the ultrasound sensor are connected to the Arduino, 2 are ground, and 1 is trigger and 1 is echo. So all the connections are made here, as you can see. And I had implemented 2 LED lights. The first one is of green color and the second one is of red color. And The jumper wires are used to make the connection, and it is connected to the Arduino Uno. Also, the power supply of this Arduino Uno is coming from this power bank, as you can see, by using this USB cable. And the next component is the smart garbage disposal truck. I basically made use of RC car chassis here. I had used two 9 volts battery to power the RC car, and this is the garbage bin in which it is going to collect the garbage. I had used two other components as well, in addition to the two motors which are going to rotate the two wheels, as you can see here. So the two other components are the L298A motor controller and Node MCU. This is our Wi-Fi module which is going to generate the Wi-Fi signal, which after connecting to our smartphone we are going to run this car by making use of an Node MCU app. So now let's come to the demonstration of the smart street lights first. So as you can see, I have one car here. If I try to run this car, after detecting the presence of the car by the first IR sensor, the first smart street light is going to switch on, and after the car passes, the second IR sensor will detect the presence of the car and the second smart street light will be switched on. And as you can see, the first street light has been switched off because the car has already passed under it. And then consequently the other street lights are also going to function likewise. So in this way we can minimize the wastage of electricity whenever there is no car passing on the street, and only when a car passes under a street light, then only it will be glowing. So in this way we are going to consume very little electricity as much needed. So now let's come to the second component, which is the smart garbage bin. As you can see, I already filled some garbage in it. Now the concept behind this smart garbage bin is that after the garbage in the garbage bin, the uppermost layer, the distance between the uppermost layer of the garbage and the ultrasound sensor is less than equal to 5, then the green light will automatically switch off and the red LED light will turn on, so that it can give us the indication of the level of garbage, so that we can operate the RC car for garbage disposal as quickly as possible. So now let me give you a demo. I'm going to fill some garbage in it so that the distance between the cap of this garbage bin and the upper layer of this garbage becomes less than equal to 5. So as you can see, the red LED light has turned on and the green LED light is switched off. And now for the demonstration of this smart garbage disposal truck, let me make the connections a bit. So the connections are being made, and after making the connections, as you can see, the L298 motor controller light has been switched on and the Node MCU is also active. It is going to generate one Wi-Fi signal. So now let's operate this car by using our smartphone. So first of all, I will have to switch on the Wi-Fi signal. And connect the Node MCU car Wi-Fi signal with my smartphone. It by default operates on 192.168.4.1 IP address. So as we have limited space here, let me give you a small demo of how I'm going to control it. So these are the directions. If I press any key, as you can see, the car has moved. So because of constraint in space, I'm going to show this only. So this is the implementation of our smart city till now, and that's all. Thank you.